So welcome back to this last chapter, and when you look at the image, what you see is I have placed a rock right in here and a rock down the road. And what I like to mention before we talk about clouds in the sky is, I see here's an arrow, is when you use the layout brush or the layout tool, you see the entire mesh of your scene as that you use as an input. And when you look at the Solaris tab, when you look at the structure itself, you see that all those USD files or USD assets are in this path, even when you only wanted to draw some stones. And this can irritate you, since you will probably think, is RenderMan or is USD now using the same mesh twice in the render? This is not the case, since this is our main branch, and because of that, this has the higher opinion in the merge process. And that means, when you remember the additional instruction videos, the quick sessions about duplicating of USD objects, you will probably remember that when we have copied one object into another by merging without giving a new name, the other object will be deactivated. And this is happening here as well. So you will not have the same geometry twice in the render. But yeah, it can be irritating. And in order to not get irritated, what you can just do is you disconnect all those inputs, and then you see only what you have drawn on your scene. So I did that already for the other brushes, but not for the draw helpers. So it's not a good idea to deactivate or to disconnect them, since we are reusing our painted geometry for projecting our lines and shapes onto the project. So please don't disconnect them, otherwise they will not work anymore. So only when you use the layout asset gallery with the layout brushes that you can use. So as you can see, I've placed some additional rocks, and now we will talk about clouds. And for doing this, I thought to myself, what we need to test out the clouds. We just need our environment, our basic rough environment without any trees for now. We probably don't even need the fence and the road. We want to see where our clouds are living. And I already prepared and tested out what I would like to show you now, since volumes are a bit tricky sometimes. So I had the volume box right in here. I activated them and moved them to the right. And when we talk about clouds in RenderMan, there are two things to mention. First of all, RenderMan can render billions of voxels without any problem. But because of the structure that RenderMan is using for optimizing the shot, you have two different ways in order to deal with large cloudscapes. And the most important thing is that Pixar has introduced a new volume thing that I have briefly mentioned in the introductions, the aggregated volumes, and those were not fully implemented yet in the Hydra delegate in Houdini. And because of that, I will not cover them entirely now. So what I will show you now is the old traditional way. And when we talk about the old traditional way, we have to think about the volume clouds as a box. That means each of those volumes has a box, a bounding box. And when you have multiple different clouds stacking into those boxes, you will get render errors. And some parts of the clouds can disappear and so on. So that means when you want to have a very thick and closed cloudscape, you have no other choice as to combine all of your clouds inside of one VDB. That means you have to merge them to combine them with the VDB combine. You have to make sure that you have not this situation that I will show you now. So when we look at the I need to go to the build tab. When we look at the cloud currently, we see we have two cloud objects, or maybe I should show it right here. So we have two densities, and this will not work. So RenderMan will only render a VDB when there's only one density. So in this tutorial, we will not create a very closed cloudscape. So this is not necessary, but I think it's worth to mention for you out there when you maybe want to have a bad weather condition or something in your image. And we are making sure in our image that our bounding boxes are not penetrating the other bounding boxes of other clouds. So, and there's a very easy way. So you load in your volume. Oliver Grotenrath has provided a lot of clouds, I guess 5 or 6 clouds, 5 clouds. And you will be able to load them as a VDB directly. So why is it not updating? So now I'm back, and this was just my NVIDIA driver that has striked one time again. So yeah, maybe I should change my operating system. I'm currently on Linux, and usually this should not be a problem, but with OpenGL there were some issues and some updates. Maybe they are not fully working perfectly together anymore, or maybe my current NVIDIA driver is too high for Houdini. This could also be a case since the recent Mesa and Vulkan updates have changed quite a lot, and this could probably a reason. So, but yeah, side effects is working on the viewport. They have announced, when I remember correctly, a rebuild of the entire viewport in the next releases in the upcoming years. So this will resolve everything, hopefully. On Windows, you will probably have no issue. And yeah, what I did is I loaded in those volumes from Oliver, and there is an issue when you think you will duplicate them, like I have shown you with geometry objects. This will bring a very big slowdown. So what I did, every time I want to have a copy of it, I copy this entire branch. And this makes it easier to work with. So this will also make sure that all of our volumes have a different name. So I use the $OS default value, but change the value to 01, and this is 00. And so we make sure that we have a unique volume. And then I applied the material with an asterisk to all above, to all the Humulus clouds above with the Congestus cloud material, but it's just a shader. You can call it and work on it like you want. And I will do the same now for the other clouds, for the Congestus clouds. So that's the big one that we have currently here. We'll call this 00, and we'll call this 01. Or maybe we do it one time. So we have it here, and we use this name from here right above with an asterisk. Maybe we should do this right here. This will make a lot of things easier for us. Here we can use the lob input prims. You cannot use the lob input prims on the render geometry settings. This will not work, as we find out recently in our last tutorial sessions. I will create a merge for all of these. And here I will use the asterisk 2 and will place a transform. Maybe we can use the transform from here. So I already pre-moved them into the view direction a little bit. So, and then we'll merge them together just to see our clouds in the sky. So deactivate. So they are all real size. So I moved them up by 600 meters and moved them away by 6 kilometers, 6.6 kilometers. So they are really large. So keep that in mind. So we will do the same right in here. So let us try. Copy and paste. And maybe we should move this cloud a little further to our position. Somewhere here. Or maybe there. Maybe we should move it a little down. So those humulus clouds are often higher and those bigger clouds are lower. So around 300 to 400 meters in general. So this is totally fine. And I will copy and paste the same position and it is working, as you can see. So now we have to make sure that our clouds are not stucking in the other clouds. And I will probably rotate this one a bit. Maybe a little more. So by rotating the volumes itself, it makes sure that we not see the same cloud over and over again. Of course, those clouds are in the direction of the wind, so we could not, it will look wrong when we would rotate them too much. But this will look mirrored. This is also what we don't want to have. So we will move them, this cloud a little closer to the camera. And we'll rotate the cloud a little bit. Maybe 120 degrees. Oh, this is too less. Maybe 160. Yeah, I think this looks way better. So a cloud here. I'm really not an expert on clouds, but so please don't judge me on those clouds here. Those little sheep clouds could be placed somewhere here. So we need a little more, so otherwise it would look artificial. Those are more random value. Just yeah, something like that. So maybe I should do it more that way. Could be okay. So 126 degrees. So we have a different version. I will move this to the right. Yeah, I'm not that happy for now since we have so much to cover with clouds. And maybe we should cheat a little bit and make those bigger clouds a little bigger in size. Maybe we can do that. I never did that. Don't even know if this is okay. We also don't know how this is looking, so I will move this side branch down, and here we have our environment, and I will merge our test environment right in here to see how it will look. And yeah, it looks a little strange. Yeah, this looks really strange. Very strange cloud. Of course, we should make it even larger. So this is not easy. Oh, come on. The viewport here. So looks way better. We have a very large cloud here and a cloud there. And maybe this cloud is looking totally wrong. And this is easier with clouds instead of having no clouds. We can even make this one a little bigger. Maybe not so big. So we should make sure that we have the impression that they are all on the same height, even when they are not. So maybe I can delete a part of this cloud right here. You can do that by yourself maybe, or you can merge. Maybe we should merge a custom built cloud by ourselves to not have a duplicate from this. And this is quite easy, and I will show you how you can do that. So you use the cloud merge. First of all, we save our scene. So then we will dive into our cloud merge. We know that we have used the congesters cloud. It was this one. This is the bounding box, by the way. And I will use this cloud twice, so I can use a transform right in here, but now I will use a VDB combine. And the VDB combine, first of all, I will use a little cheat. It's better for the viewport. So, and we will do another right here. So this will make sure that the cloud is not looking the same. So, but what we have to do is we deactivate this merge. This was just for helping us. And we will merge them together to have only one single VDB. And here we go to Where is it? I guess it was maximum. Yes, with maximum you will join the volumes. And we will do it again for the other cloud right here. There. So here we have our iteration. And all what we have to do is we have to make sure that we have a new name. Our original name was the cumulus congestus, and I will create a cumulus congestus B inside of our geo folder in caches. Caches chapter, and call this chapter 7, right? Yeah, chapter 7 congestus bvd.vdb accept, and I will bake this out. It's baked now, and I will exchange our write congestus here with our cached version. So caches chapter congestus B, and here we have it. So this is now looking really, really great. So we don't have a copy of the old one. So now comes the fun part, and hopefully everything will work. I will save this file first of all, and I will do a small test render in the viewport just to see if the volumes are working and assigned correctly. So we can do this right from here. We will get dark clouds in case the materials are not assigned properly. But everything seemed to look great so far. We have a black one in the background, okay, and the black one here. There can be multiple reasons for that. One reason could be that we have limited our integrator, the continuation depth. This could be one reason. As you can see, the reason for that was that this bounding box has covered essentially the cloud in the background, and the continuation depth is only penetrating for 6 times now. So all rays behind will get blended out and will be black. So the material is pre-defined, and you see it really looks great. And I think we should move this one to the left. So I will forward this process and we'll try to find a really good spot for this big cloud. So yeah, this is the speeded up version, and what you can see is that we had a black box also in the background, so I needed to raise the continuation depth a little more. And yeah, the placement of clouds is really a tricky thing and not that easy to get a realistic sense, since the clouds should move closer to the horizon by distance, and when they are too low it will not work. Here I have blended in the windmills, the energy generator, and tried to see how it will look with those generators in front. And here I also placed the clouds in different positions just to have a better composition. And it was mostly real time, so the feedback from the render engine is really fast. And yeah, I now come back to original speed. So I'm back, and I think this looks really nice. I have decreased the density of those bigger clouds so that they are getting a little brighter and not looking so dark and so bad. And I see we have a little cloud issue here. We will resolve this very quickly by moving this cloud a little more to the side, so this will not look that symmetric. I scaled those humulus clouds a little bit into different directions to have more variety on the sky, and I think I can now live with the placing. It doesn't look that bad, and yeah, I think this is totally fine, and I will use those clouds. So what we will do, I will stop the render. And I will, of course, resave the file that we already have. And as you can see, the RAM has a little jumped up because of our editing and the caching and so on that is taking place. So I will bake out this USD layer. And what we don't need anymore is all of our previews. So we don't need the render engine and so on. Maybe the render engine. Yeah, maybe we should think about how it will look in the final image. Yeah, we could also render a different AUV out of those clouds just to have more space and compositing to work with them. And I'm currently thinking about, and maybe we should do this. So I will move this render right here to this one. Here comes the tricky part. So we of course need our light. We can use the same light that we already have. We should delete this for now. And this is our entire cloudscape. We will move this a little down. So those are our clouds. We don't need the camera. We don't need this merge, but we can do a network knob. And I will create a separate render path. So what I have to have is, we have to have our lights right here. No, that's the scene. We don't need the scene. We have to use our lights, and we of course need to have the same camera without the entire path. And what I can do is I can merge the light and the camera into our shot. So I will unlink this one and we'll do a separate merge only for our camera. So we will link it here and we will uncheck this here. So we don't want to see the entire shot. Yes. Yeah, you see it's very, very dense. So that means we have now, I will call this clouds, and we'll call this scene. Here we will do also a bake of the entire action. I will call this scene clouds, or I will call this full clouds. Makes more sense. So this is our cloud branch, and that's our scene branch. So new layer, full clouds. Oh, no, plus. Save it out. Reload it. And this should be everything that we need. So organizing everything a little bit, make them black as our outputs. Maybe, yeah, black is always good for outputs. So we have a cloudscape that will be rendered and composed in, and we have our scenery, and all what we have to do is we now have to look if we have a proper alpha. And I will save this as a new scene. And here I will take a look at the render layers for our clouds. And we don't need the normal pass. We don't need the UVs, just a waste of energy and time. We don't have to use the beauty pass. We only want to have the direct diffuse and the indirect diffuse. The indirect diffuse will also give us the chance to work on the so-called powdering effect a little more when we will probably get some arrays of this in the render, so we can deal with it in compositing. And we also need the alpha and the CI pass, of course. So I will check this render first of all. Render to mplay. I will forward this. See you in a second. So what you can see right now in this test render of the clouds, that I have used the depth AUV as well for rendering, and in the blue channel of this layer we have our C value, and we can use the C value in compositing to deal with a distance and bleeding out of colors on the clouds itself, so that we get a sense of atmosphere. So when we go to the CI path, it looks really great, and it's really rendering quite fast. So rendering those clouds in full HD will not take any longer than 10 minutes or so to full capacity. This took only 2 minutes, so in 10 minutes this would be clean. But we also could, of course, denoise it. So I am very pleased with the result of the clouds. So I will now save this entire scene as our final result. Call this build layer chapter final result. And I will render it in full capacity, and I hope you have learned really the essence of using USD. You have seen some mistakes that I did. All that work will help you to get away with the fear and have a lot of fun by playing with all those assets that you will receive with the entire workshop. And yeah, I hope to see some iterations. Make sure that you will link a Pixar and side effects as well as myself. Yeah, so that we can see what you do with that. You don't have to do that. You can use the assets, of course, like you want. But it would be nice also for me to see what you achieved with all the assets. And yeah, we don't even have used all the assets in the shot, so we not have used the willow trees and all the other plants. So I think you can build very nice iterations of this project or build your entire scene from scratch. Keep also in mind that in the future, RenderMan will provide support for XPU, so you will be able to use all those llama shaders in the XPU and can render the image even faster with a bigger, of course you would need a bigger GPU, but you will be able to render it as or with XPU. You can even do this now, but then you will probably have to switch all the shaders from RenderMan to the surface shaders that we had in the past. So I think it's better also for optimization reasons to use to wait until XPU is ready for Llama. What I like to show you now is the final result. And before we jump into DaVinci Resolve and Houdini, the Houdini denoising comp, I want to mention that I needed to resolve a little error that we had in the scene with the UVs on those mid-range planes. So I needed to add new UVs to those objects, except the foreground, but the entire background objects, to resolve a texture mistake that I did. So when you want to work with this scene and when you want to iterate on the scene, it's better that you will use the final result, the final chapter of this entire project. And I think this will provide all the final quality that you will see in the image. I have rendered the image to 4K as mentioned in 2 layers, and then I moved over to TOPS. So I will also provide the TOPS network in those files. So as you can see here, and I simply loaded the scene in the clouds, but that I have named them wrong, no problem. And yeah, I essentially rendered out the scene first and then the clouds in one go, just automatic. As I mentioned earlier, I switched the job to a single license work mode. And after that, I have denoised the entire image, and in Houdini inside of COPS. So the final result was quite noisy. So this was the final result. I mean, it doesn't look that bad. But we have some really big amount of noise also in the trees. And Houdini's Intel denoiser, AI denoiser, is quite nice in doing the denoising process. I don't render out an albedo plane. I just used the image itself and the normal path. This is highly important. Denoised the result, and this takes a second, as you can see, but it was very smooth. So what I did is I averaged the render result with the denoised result. This is something I highly recommend in all denoising processes, since the colors and the peaks and the deep blacks of both worlds will be combined with an average, and then I have saved it out, as well as for the clouds. So the clouds were, yeah, they had no noise anymore. As a little side fact, the image itself took about an hour to render, 1 hour and 6 minutes in 4K, in full 4K. The clouds itself took around 8 minutes on my machine. And I only have 6 cores, aka 12 threads. and Intel 11 600K slightly overclocked, and I use the AVX 512 feature. This is highly important. I have checked it myself, and without AVX 512 activated in the motherboard, this llama image would render about a third longer. So when you have AVX 512 and the Intel machine, make sure that you activate it in BIOS so that you get the full performance on rendering. And yeah, later I moved over to DaVinci Resolve and I worked on the compositing. So the compositing network is quite big. Maybe we can deactivate that. This was just the signature. So without saying too much about the compositing here, I worked in ACCG, this entire image. So we have to activate that. So this is the original one. And then I added some defocus to the lines above. They were a little bit too harsh. I make them black. This looked way better. So I pre-multiplied the background. I added some fog based on the P path. So I use the position paths and the blue layer of it to get a new mask. So something like that. The nice thing about using the P path is that the P path is always based on camera. So it's the perfect real world depth value. It is a value that has more gradation steps than the normal C buffer. So I highly recommend to use it even when you have to use very low values. You have to crank down the gain by 10,000 times. But it is working. So then I loaded in the clouds and did some color corrections on the clouds to shape the clouds a little bit more, to blur them a little bit. And I also did the same here, but with the depth path that we rendered out to have a new mask. And yeah, to create a new sky. This is the sky that I created, which is a fade into the brown area, a little white. It's just a mix above one. And then I merged everything together here, and this looked really nice and great. And yeah, so then I additionally painted in some dodges. So I used the dodge brush to crank up the rock, which was really dark in this situation, but I made it a little brighter. I painted out some highlights to give a more living sense. Those highlights create the impression that the crops are moving in the wind. Then I added my signature, and I added some glow here and some highlights, reflection highlights, glints, sparkles, and so on here as well. And then I transferred everything to Rec 709 and moved over to the color correction tab in DaVinci Resolve. And here I essentially changed the color correction a little bit. I created the init color correction. Then I color correct a little bit more on the curves, so a little more contrast. Then I sharpened the image. I added a vignette, a slight vignette in the background. I added a little bit more glow here in the center. I added a artificial lens flare from the sun, which is right here somewhere. And this makes it more, yeah, realistic in my opinion. And then I added some film grain. Adding film grain to rendered images has the disadvantage that the image get bigger in size, in file size. But the other nice advantage is this is a necessary step to make sure that the image don't get gradation lines when you load it up to Vimeo when it is an animation, or when you loaded it up to social media. So film grain or any type of noise in your image will always make sure that those gradation curves during the compression process on these platforms will not influence the result that heavy. Of course, social media has always lesser quality than the original image, but it helps a lot. So I think the result is really, really nice. I also have worked a little bit on the composition in the first place, and I want to show you that simple result right here. So I need to jump up here a little bit. Don't want to show too much, but I did a layout test with the previous compositing. I will place it right here. So, and yeah, those are essentially the layout, the resulting layout that I was mentioned in the first place. I don't build it as accurate as possible. I was not forced to build the compositing that way, but somehow it has worked quite nicely. So the boulder is exactly on the golden ratio line, and the machine and all the angles, all the viewing angles are tracked to the machine, hopefully, and we have a really rounded image, in my opinion. And this is something that you should always aim for. So always build the image exactly how you feel it's right. This is something that I did with the rock. I tried to place the rock here and there, and I also placed the rocks here, and it doesn't felt right. And then I decided to move it somewhere here in the front, and by accident or by somehow the boulder exactly moved to the right position without even checking the golden ratio before. So in the end, I think this is working nice. All those guiding lines in the image are pointing towards the machine. And yeah, I hope you learned a lot of things during this tutorial session. And yeah, I want to say thank you for all of you who watched all these hours, gaining all the informations. And yeah, let us hear some feedback, and we hope to achieve that you will find more fun in using USD. And yeah, of course, you can join our Discord server, so the Discord server from Pixar itself. You can contact Side Effects on their website, and you can also contact me on Behance as well as on my RenderMan for Houdini Discord server. So when you have issues with the tutorial and you don't understand something, or you have a question on some specific things, you can move to those places and can ask people and even myself, and then we will look if we can help you. So yeah, see you. Bye.